Hi everyone, welcome back to GAMT-LF channel, and this is Dr. Karthik, and today we're going to look at chapter 19 in the class 11 of the NCERT textbook on biology. So this chapter is pretty interesting from the GAMT point of view because the entire chapter um, is GAMTable, if you can call it that way. So which is going to dive straight in. Okay, so this chapter kind of deals with the hormones, endocrine glands in the human body. Okay, the first we're going to look at hypothalamus and pituitary. Okay, so you just need to know the definition of hormones. So hormones are non-nutrient chemicals that is intercellular messengers. It's not intracellular, it's intercellular messages, and they're secreted in small quantities. Okay, so these are the main features of hormones: non-nutrient chemicals, which is secreted as intracellular messengers, and are secreted in small quantities. Okay, so usually the glands that secrete hormones are called endocrine glands. Okay, the other type of glands are exocrine glands, which secretes enzymes. Which the difference between endocrine and exocrine glands, or exocrine glands secrete their secretions via a duct, while the endocrine glands, the secretions go directly into the bloodstream. Okay, so let's start with hypothalamus and the pituitary, which is the first endocrine organ in the human body. So this is kind of diagram given in your NCERT textbook. The diagram conveys a lot of messages, so we just have to pay close attention. So there are two types of pituitary. There are anterior pituitary here, and there is posterior pituitary. Okay, if you look closely, if you look at the neurons from the hypothalamus, so they have shown two different neurons in the hypothalamus. The first neurons, they have a nucleus here, and I kind of secrete their secretions, which actually enter into a portal circulation. What is a portal circulation? So normally a circulation starts in an artery, goes into your capillaries, then goes into your vein, right? That's normal circulation. Portal circulation starts with capillaries, becomes an artery, and then ends in capillaries. Okay, so that is portal circulation. Apologies for the super diagram. Okay, so all right, so we have a pituitary portal system where there's capillaries in the hypothalamic area, there's capillaries here in the pituitary area. So the enzymes secreted by the hypothalamus in this part of the hypothalamus are absorbed by the portal circulation, the capillaries here, and they're transported into the anterior hypothalamus. And then there's another group of neurons in the hypothalamus where the cell bodies are located in the hypothalamus, but the axons extend all the way directly into the posterior pituitary. So the posterior pituitary is under direct control of the hypothalamus, where the anterior pituitary has this portal circulation. Okay, I hope that's clear. It's kind of important to understand the concepts here. Okay, all right. So let's go into the GAMT for the hypothalamus and the pituitary. Okay, so the GAMT that I have here is an office table, maybe a broken office table, and a very wobbly chair, and a laptop that doesn't really work. Okay, these are the two things that you're going to use for hypothalamus and the pituitary. So the table is, the surface, the top of the table is not straight, it's uneven, and then you have two limbs on either side. You have a desks on one side of the table, and then that's all the table is. It's a very flimsy table, if you may call it. And then you have a chair, which is not bad, so far it's been good, but there's no armrest, and then it has only two legs, so you might actually fall. So I don't know who invented a chair with two legs. There you go. And then you have the old laptop. That's all for the table, and the old laptop. So you have a keyboard area. There's something in the screen, and then you have this plug point, and then you have the mouse and the keyboard. Okay. And am I missing anything? No, not really. Okay, so that's it. This is the GAMT that you have to remember for pituitary and hypothalamus. Okay, so let's get into it. So first, let's start with the hypothalamus. So the hypothalamus, as we saw, is located in the floor of the brain, or the diencephalon. So it secretes two types of hormones. One is stimulatory hormone, the other one is the inhibitory hormone. Okay, so there are two specialized features of the hypothalamus that we discussed already. You see the two legs of the table. This one stands for one P, this one stands for another P. Okay, so this P stands for posterior pituitary. So what's special about posterior pituitary? So as we saw already, posterior pituitary is under direct control from the hypothalamic neurons. It's kind of an important concept to understand. And portal circulation is the hypothalamus is connected to the anti-pituitary via the portal circulation. Okay, so it's important to get these two specialized concepts in your mind when you're talking about hypothalamus. Okay, and as we saw already, so the hypothalamus has two hormones, stimulatory hormone and inhibitory hormone. So the hypothalamus basically controls the pituitary gland. The pituitary gland is the master gland of the endocrine system because it orchestrates all the other endocrine organs. The hypothalamus is the master of the master, okay, maybe the grandmaster of the endocrine system. So it produces two types of hormones. It can be the stimulatory hormone, which actually stimulates, as the name implies, stimulates the pituitary to secrete the hormones, or it can be inhibitory hormone, which inhibits the secretion of the pituitary hormones. So the examples given in NCRT is what you're going to remember with this table. So you see the top of the table, as we saw earlier, it's not straight, it's very wobbly. I don't know who can work at this desk. Maybe I can, with my fantastic handwriting. So this stands for S, stands for somatostatin. Somatostatin is an inhibitory hormone which inhibits the growth hormone secretion from the pituitary. Okay, then you have the desks on the side, which kind of stacked on top of each other. It resembles the letter G. Okay, so these desks stand for the letter G and R has G, so it stands for GnRH, is gonadotropin releasing hormone. Gonadotropin releasing hormone. Okay, so this, as the name indicates, stimulates the release of gonadotropins from the pituitary. Okay, so that's all you need to know about hypothalamus. Hypothalamus have the posterior pituitary and you have the portal circulation, the two specialized circulations. You understand what it means. Then you have somatostatin and GnRH. One is the inhibitory hormone, the other one is the stimulating hormone. Okay, all right, are we clear with the hypothalamus? Okay, next we're going to move on to the pituitary. So the pituitary, coming onto the chair. So first we're going to deal with the neurohypophysis, then we're going to go into the adenohypophysis. Okay, so you see the chair here, the top of the chair resembles the letter A, which stands for adenohypophysis, which is also for another name for anterior pituitary. And the posterior pituitary is also called the letter N, which is on the chair, which stands for neurohypophysis. So as we saw, as I told you before, we're going to start with the neurohypophysis first because this is a little more straightforward. The neurohypophysis secretes two hormones. Okay, so the bottom of the chair again is very wobbly, like the table. So that stands for S, which basically stands for sella turcica. Sella turcica is the cavity in the cranium in which the pituitary is situated. So that cavity is called sella turcica. Okay, it's covered by a very thin plate of bone. So the neurohypophysis, okay, secretes two types of hormones. See the V here for the two legs of the chair stands for vasopressin. Okay, and the wheels stands for the letter O, which stands for oxytocin. So what does vasopressin do? The vasopressin is also called anti-diuretic hormone, ADH. What is diuresis? Diuresis means you increase the urine production. Okay, anti-diuresis means exactly that, which reduces the formation or reduces the urine production. Okay, so the vasopressin acts by reducing the urine output. How does it do that? It increases the absorption of sodium and water from the distal convoluted tubule. Okay, so vasopressin causes reabsorption of sodium and water from the distal convoluted tubule, and it's called anti-diuretic hormone. Okay, the other hormone secreted by the neurohypophysis is oxytocin. The role of oxytocin is increase in smooth muscle contraction, so it works both in the mammary duct, where it helps in the in pushing out of the milk. It also helps in the uterine contraction, where when oxytocin is released, it helps in the contraction of uterus, which kind of pushes the baby out. Okay, so oxytocin increases smooth muscle contraction. All right. So are you guys clear? The neurohypophysis, the seat of the chair. Neurohypophysis, two hormones, vasopressin, also called antidiuretic hormone, and oxytocin. Okay, that's clear. Okay, that's neurohypophysis done. All right. Now we're going to adenohypophysis. As we already saw, the chair, top of the chair resembles the letter A, so we're going to use it for adenohypophysis. We already covered the neurohypophysis. So coming to the laptop, okay. Now look at the outline of the laptop here, okay. That resembles the letter G. The G stands for growth hormone. Of all the hormones secreted by the pituitary, this is the only hormone which actually acts directly in the organs, doesn't act indirectly through other mechanisms. Okay, so growth hormones, as the name implies, is essential for the growth of the organism. If you have high production of growth hormones, you get gigantism. So increase in production leads to gigantism. Decrease in production lead to dwarfism. It's also called pituitary dwarfism. Increase in growth hormone in adults. So once you grow after your puberty, adolescent period, the bone growth eventually stops. So there won't be any more epiphyseal plate, right? So you can't really grow taller after your growth plates of or finished fusing. So if the growth hormone production is increased before the growth plates are fused, you get what is called gigantism, where legs and hands can grow really tall because growth plates are still active. But once they become an adult, there's no longer any new growth plates. So which means that the person cannot become taller, but they develop other features. Their voice becomes hoarse, their hands become really big, they have crude facial features. So this is called acromegaly. So acromegaly is caused by increase in growth hormone production in adults. Gigantism, increase in growth hormone caused in prepubertal patients. Dwarfism is decrease in production of growth hormones. Okay, you all know Lionel Messi was suffering from dwarfism. Not dwarfism, sorry, he suffered from growth hormone deficiency. So he has to get the growth hormone shots while he was in the soccer club in Barcelona. Okay, so growth hormone, all right. Okay, so next thing, see the display in the laptop is kind of broken. So this broken display stands for the letter T. We saw earlier in glycolysis, this kind of looks, this we use this for alpha ketoglutarate. Here we're going to use it for T. The T stands for thyroid stimulating hormone, stimulates the thyroid thyroxine secretion from the thyroid gland. And you have the mouse, so the cord attaching the mouse to the laptop is L, stands for LH. LH is a luteinizing hormone. The mouse itself resembles the letter F, which stands for follicle stimulating hormone. Both these hormones together are called gonadotrophins, okay, because they act on the gonads and they're called gonadotrophins. So what does luteinizing hormone do? So luteinizing hormones, in males it increases androgen production, okay. Females, it causes ovulation, very important, also called maturation of corpus luteum, which actually secretes progesterone. Okay, as you look closely, the luteinizing hormone increases the hormone production from the gonads. Okay, that's kind of the main production. So maturation of corpus luteum, ovulation, increase androgen production. Follicle stimulating hormone, as the name implies, stimulates the growth of follicles. So in the females, it stimulates the growth of ovarian follicles. In male, it stimulates the growth of, there's no follicles, but instead they have spermatids, spermatogonia. So it stimulates, it helps in the process of spermatogenesis. Okay, so follicle stimulating hormone, as the name implies, stimulates the development of follicles, both males and females. Luteinizing hormone increases the endocrine hormone production from the gonads. Okay, so these two together are called gonadotrophic hormones. As we saw already here, hypothalamus secretes something called gonadotrophic releasing hormone. It also secretes other releasing, other stimulating hormone, but these are the only two examples given in NCRT, so we're just going to go through that, okay? Right? And then we have the cable that goes to the power cord, so that resembles the letter A. So we have ACTH. ACTH stands for adrenocorticotropic hormone. As the name implies, stimulates the adrenal glands to secrete more steroids, okay? And then we have the plug point itself, stands for the letter P, so it stands for prolactin. Prolactin, okay, so the prolactin is responsible for all the development of mammary glands. And then you have the M, which is the plug itself. Resembles the letter M, stands for melanocyte stimulating hormone, which increases the production of melanocytes, okay? There's one more thing that you guys need to know. So that's all about the pituitary and the hypothalamus. What are the different hormones secreted? What are their functions? So as we saw earlier, there are actually there are three segments of the pituitary: the anterior pituitary, the intermediate, and the posterior pituitary. Right. So the intermediate pituitary it's kind of becomes almost fused. It's kind of rudimentary and almost fused with pars distalis, and the melanocyte stimulating hormone is produced by the pars intermedia. Okay. This again has been asked multiple times in the previous year questions, so we just have to pay really close attention. The hormone secreted by pars intermedia is melanocyte stimulating hormone. Okay, pars distalis is anterior pituitary, and we already saw what are the hormones secreted by the anterior pituitary. So just gonna close your eyes, remember the laptop. You have the growth hormone, thyrotrophic releasing hormone, you have the luteinizing hormone, follicle stimulating hormone, prolactin, ACTH, and melanocyte stimulating hormone. The melanocyte stimulating hormone is secreted by pars intermedia. Okay, pars nervosa is also the other name for posterior pituitary. The hormones secreted by the posterior pituitary are oxytocin and vasopressin. Vasopressin is ADH, oxytocin smooth muscle contraction. Okay, so that's the hypothalamus and pituitary done. All right, so very quickly let's see what are the structure stuff that we covered. So we saw that hypothalamus has both stimulatory and inhibitory hormones. Okay, so it releases somatostatin, which reduces growth hormone production. It increases, it also produces something called GnRH, gonadotropin releasing hormone. Then we talked about the posterior pituitary, which is under direct control of the hypothalamus. And then we also talked about the portal circulation, which links the anterior pituitary and the hypothalamus. Okay. And then the neurohypophysis, you talked about sella turcica, which is the cavity in the cranium in which the pituitary is located. Talk about neurohypophysis, which secretes vasopressin and oxytocin. We looked at vasopressin, which is ADH, also called antidiuretic hormone. Oxytocin, smooth muscle contraction. Okay, so adenohypophysis, anterior pituitary. The other name for anterior pituitary, it secretes growth hormone, causes gigantism, dwarfism, and acromegaly. Thyroid stimulating hormone, thyroxine stimulating, thyroid stimulating hormone. You have luteinizing hormone, follicle stimulating hormone. Together, these are called gonadotropins. And then in luteinizing hormone in males, increase the androgen production, and in females causes ovarian maturation, ovulation, and also maturation of corpus luteum. Okay, follicle stimulating hormone, it causes spermatogenesis in males and ovarian follicle development in females. Okay, and then coming on to this side, ACTH causes adrenal cortex to secrete more steroid hormones. Prolactin is essential for the mammary gland formation. Melanocyte stimulating hormone secreted by pars intermedia here stimulates melanocytes. Okay, all right.